In this series of videos, we're going to learn how to balance redox reactions, which works differently than regular balancing as all redox reactions contain charge. This means that either the reactants or products are going to have more positive or more negative charge than the other. Therefore, the way that we balance charge, rather than by adding electrons or protons, since electrons cannot exist by themselves without an oxidation reaction to free them, and adding protons gets into the realm of nuclear physics, so therefore we're not going to use either of these. What we use to balance charge is either by adding acid in the form of H+. Yes, we do write the acid as H+ rather than as hydronium, or base, which we write in the form of hydroxide. And we can see, because acids contain positive charge and bases contain negative charge, we can use these in order to balance out the charge. Now, the first thing to do when figuring out how to balance a redox reaction, or a half reaction in this case, is to figure out whether the reaction is a reduction or an oxidation, which we can do using oxidation numbers. So we know that any element, as long as it has no charge, is going to have an oxidation number of 0, and we know because oxygen's oxidation number is -2, -2 times 2 is -4, that our transition metal here has an oxidation number of 4, meaning that when we go from +4 to 0, we are decreasing the oxidation number, which means that we are adding electrons here. Therefore, this is a reduction reaction, and this is useful, as we will see when we start balancing this. So because a battery is basically a controlled redox reaction, it involves the flow of electrons from one point to another, and the reason why we need an acid or base within a battery is that this acid or base functions as an electrolyte, that being the ions within a solution that makes the solution electrically conductive so that electrons can move from one point to another through that solution. And in batteries, this electrolyte is either going to be an acid or a base. Now, in this case, we've designated an acid electrolyte. We will talk about how to balance redox reactions in base electrolyte in a separate video. Now, even though redox balancing looks fairly complicated and looks like there are quite a number or a large number of steps, as long as you follow these steps in the correct order, you basically cannot get a question wrong. So the first thing to do in a redox equation is to balance what we call the major atoms of the equation, which is simply any atom that isn't oxygen or hydrogen. Since Ru is the only element that we have here, and since we have one on each side, this is already done. Now, the next thing to do is balance the oxygen within the reaction by adding water molecules to one side that needs it. So the way that we do this is we see that our reactants have 2 oxygen, like so, meaning that in the products we would add 2 water molecules like this, so that our oxygen is now balanced. Now, the problem by adding oxygen is that we've also added hydrogen here, but that's what we can use acid for. So the next thing to do is balance the hydrogen, which usually becomes imbalanced by adding water, and we can do this simply by adding H+ to indicate the presence of acid. So we see in the products that we have 4 hydrogen atoms here, meaning that we can balance this by adding 4 H+ ions, like so. Now, the final component of redox balancing that is unique to redox balancing is to balance charge. So we can see that the charge of our reactants is +4 from the 4 H+ ions, but that our products have no charge at all. So the way that we balance charge without adding any mass to either side is simply by adding electrons, and we can see that our products have a charge of 0, which means that we can balance the reactant's charge simply by adding 4 electrons, because -4 plus 4 is equal to 0. So, once again, by following these 4 steps here, we have not just balanced the mass of our half reaction here, but we've also balanced the charge. And we can see that because electrons are a reactant rather than a product, that means that our compound is gaining electrons, and therefore we have a reduction reaction, which is exactly what the oxidation numbers predicted. In the next video, we're going to look at how to balance half reactions using basic electrolyte rather than acid electrolyte.